Hello everyone, welcome to this new webinar about SCANeR 2021. So if you have any questions, please don't hesitate to write them on the chat. And now I just let Thomas speak. Thank you.
Hello everyone, so welcome to this new webinar to discover SCANeR 2021.1. I am Thomas Nguyentat, I'm the product director of SCANeR Studio, and I will present you all the new features that we have in this version. So just to start, I wanted to start with the SCANeR timeline to remind you when we release our new version. So you can notice that we have changed the number of the version. So we switched to 1.8, 1.9 to year with the .1 version, which is always the first release of the year, which contains all the new features, and the .2, which is a refresh version with some new minor features and bug correction, but you also have the bug fix release all in between. So we are releasing the next version of SCANeR, the 2021.2 in May this year, and the next version will be the SCANeR 2022.1, which will be released by the end of this year in November. So what are the key features of this new version that has been released at the beginning of the year? The first big new feature that I will present you more deeply in the next slides is that we have this new physics-based rendering. We also have new standard support. You know that it is important for us that SCANeR is a very open platform, so we now support LSDs, ROS, and OpenCRG. We have a new sensor, which is a light sensor. We have a new physics-based Lidar sensor also. We have a new feature dedicated to vehicle in the loop application. We also have been doing some improvements and deliver new tools to facilitate the deployment of massive simulation. And we have a new tool which is named Sensor Viewer, dedicated to the interactive analysis of the sensor's output and graphical objects in the simulation. So what is new also is that we have released a new packaging for SCANeR. So you know that SCANeR has many features, and we have tried to facilitate the packaging of SCANeR by regrouping this feature into pack, and pack are dedicated to application or to simulator. So we have pack dedicated to user application, so that are all the features that you need for certain applications. So we have AD-ADAS, we have the physics-based sensor for engineers working on perception. We have the headlight, we have vehicle dynamics, military, and human factors. And we also have packs that are related to how you use the software, in which environment, what you need to connect to this software. So we have a pack dedicated to real-time applications. So for example, hardware in the loop, software in the loop. We have pack for massive simulation. We have pack to connect to driving simulators, and we have also feature pack, dataset pack that add new assets for your simulation. So we have 3D environment, and we have also scenario, the NCAP and regulation scenario for the Euro NCAP and the US NCAP, and we also pack dedicated to education and to training. So now let's talk about the new rendering engine feature, which is delivered in this version as beta version, but you can still use. So we have chosen Unreal for this new rendering engine, and the aim of this slide is to explain and to detail why we have chosen Unreal. So the first thing is that Unreal has many advantages. Okay, so it's one of the most advanced and popular 3D engine of the market. And what was very important for us is to really drastically improve the visual quality that we can offer, and to offer this for all the applications that are covered by SCANeR, which means not only a driving simulator but also camera perception, camera modeling, and so on. So we want to be able to deliver photorealistic quality images. Okay, it's very important. So that was the first motivation, was really to improve the realism and the quality of the images that we can produce. And to do that, you also have to think about optimization. Okay, so it must be realistic, but it must also be efficient. So that means that you have to use the GPU, and it has to be optimized for being able to deploy on multiple GPU, multiple computers, and so on, and to use all the feature from recent graphic cards. Also, one feature that was very important for us was the physically based rendering, because it not only must be realistic, beautiful, but you must be able to trust the result, and we must be able to reproduce what exactly the condition that you have in reality. So the physics-based rendering was also a very important criteria for us. And of course, all the quality that you can gain and the reason that you can gain from ray tracing that are also supported by recent graphic card was very important. So the performance also was very important, because we have many real-time application, we have many human in the loop or hardware in the loop application, and then we must ensure that all the images are delivered at the proper frequency, with no delay. So that was very important. It's also, and I'm sure that if you follow the news, you can see that every day you have a new feature for Unreal Engine. You have new acquisition from Epic Games that also bring a lot of value to Unreal. So it's really the 3D engine on the market that evolves the most and has the most advanced features. Also, technically, what is important for us is that it's available in C++, which always ensure that you can provide very efficient and close to the computer's performance. It's multi-platform, so it's available on Windows, but it's also available on Linux, and we have more and more use cases where we want to use Linux. We have access to the source code, which means that we can always debug and analyze the problem, and we are very free to adapt and to extend the engine if we need. You have a lot of option and feature for asset management, which is also very important, because you have to be able to input a lot of data and your own data, and you have to be able to have a very flexible workflow to put your data and your assets in the engine. You also have this asset and plugin store that offer not only additional feature, but also a lot of content, and every month you have a free content. You have very high quality free content that you can integrate into your simulation, and it has a very interesting business model, because it's royalty free. So which means that we are not limited in the capacity of deploying the software, but it's also very free and simple to use by our customers. So anybody can download a version and modify asset and adjust the quality of the assets that it wants to use with Junction. So many advantages. So now let's talk a little bit about the architecture, which was really the aim of this new development, was to be able to put in place an architecture that will be then used for the next coming year, and on the top of this architecture we'll be able to add a lot of feature and to convert all the feature that we have in SCANeR and to make them compatible with these new models. So the first thing is that you have a standard SCANeR architecture where you have a SCANeR Studio, you have the 3D assets, you have the simulation bus, and you have all your modules. So there is this new module, which is the U-Renderer. So one important thing is that you still have the traditional visual module. Okay, it's nothing that will, for the moment, totally replace the existing. You still have all the existing 3D rendering feature, but it's a new module, an additional module, which is available in this version as a beta version. So you start this U-Renderer module as any scanner module, and it will be very simple. This module will take care of starting the rendering engine feature. Okay, and this feature will use all the high quality Unreal 3D assets. Okay, so you don't have to do any manual conversion. So how it's done completely automatically. All your existing assets that you need for your scenario are automatically converted using generic high quality materials. So we detect the material and we replace them by more advanced material, which means that you don't have to have any skills in Unreal, any skills in programming. Everything is done for you. You just have to launch the module, start the simulation. It will be automatically converted, and you will be able to have the high quality rendering of Unreal. And if you need also to create and to generate specific terrain with specific material, you can also directly assign your own material and directly generate for the Unreal format. So it's very interesting because you can do a lot of things. You can have the quality without having to use by your own Unreal, so you don't have to be trained for that and to have any skill. So this is the standard workflow to use Unreal. Okay. But we can also propose another workflow, because we know that we have a lot of our users that wants to do more advanced thing, and they want to be free and they have skills in Unreal, so they want to be able to use all the features and to use assets from the stores and so on, and they know how it works. So we propose another workflow which is for more advanced user, but you have to know what you do, and you have to have some skills in Unreal programming. So when you have that, then you can use the Unreal editor to do many things, and we provide a template project for Unreal. So when you install SCANeR, you can also install this project, and it will register new plugins. And when you create a new project, then you will have a SCANeR template project. With this project, you will be able to import assets from SCANeR to modify them. You will be able to prepare assets from the data store, or modify assets that you have on your own Unreal assets, and you will be able to export them in the proper format that is needed by SCANeR. And what you can do also, you can directly run the simulation in the Unreal editor. So it is very useful if you need to adjust the quality, and if you want to verify how your scenario renders or perform, you can directly run the simulation to be run in the editor. And when you are ready, you can export the assets. You can also build your own application if you need to customize and modify the rendering, and then you can run the simulation, and you can use also the application that you have generate in place of our Unreal application. So a lot of flexibility for advanced user to customize, to put their own assets, and to modify the quality of all the assets and the runner. So enough talk. I will I show you a little video to show you all the features that we have put and that we support. So now you can see that you have a very beautiful and connected to the scenario and to the simulation environment simulation. You can change the time of day, you can change the weather, you can put water on the road, or you can put rain. You have all the lighting, a very advanced lighting effect. You can use assets from the data store. You can see it's very high quality asset. You can also run your NCAP test and run a lot of very beautiful simulation by modifying the environmental condition with this very high quality rendering. This is already available, so it is a beta version. So we are still improving a little bit the feature, improving the performance, improving the documentation, but you can already try it and use it. And in the next coming version, we will improve the feature. So one limitation with this beta version is that for the moment it's limited to one screen, so we don't still support multiple screen for driving simulator, for example. But this will be available in May. So we are working on this new feature, and it will be available very soon. Okay, so now next feature, some new feature about environment modeling, which are available in the foundation pack, and which been available for any SCANeR user. So a new version to a new feature to import point cloud directly in the editor or in the simulation. So you can you have a tool to convert and to adapt your point cloud data. You can directly it can be optimized, and you can put a level of detail to have a smooth rendering, and it can be very useful to build your scene, because you can verify all the placement of all your objects, also the rendering of the road, to verify that it really match the point cloud acquisition that you would have made. Also, some improvement about the 3D generation, mainly for advanced and complex intersections. So we are now generating data that are closer to the input data, and you have more details in the intersection, all the marking and so on. We also have put this new feature for the traffic driver. So now the traffic driver is able to drive in reverse. Okay, so you can have application where your driver can follow any road geometry configuration to drive this in reverse, and this maneuver can be fully triggered and controlled by script, which means that you can program scenario with a vehicle that stops and engage the reverse gear, for example, and it will be able to follow the road. Also, a new small feature that can also be very useful if you have a scenario with multiple parameters and you want to rapidly launch a new scenario with this new parameter, but you don't want to save your scenario. You want to keep the original version. Then you can very easily start the scenario, modify the input parameter, and start and stop new scenario to find the proper parameter set. It's very easy and doesn't modify the scenario, so you don't have to open the script, modify the variable value and so on. We also have worked a lot on the performance. So we wanted to be able to improve the global computation time of SCANeR. So we have worked a lot on the SCANeR API. So we have gained a lot of performance, and we have a new optimized version of the API directly. We can use directly the structures in C++, and it can be 100 times faster than the old version, but everything is still compatible, so you don't have to rewrite everything, but you can gain performance for your system on the task. For example, we have also speed up the recording, we have speed up the sensor time computation, and you also have a new option in offline scheduler when you can do some parallelization even in offline, so it can be less reproducible but faster. So if you need to have a result, your result very close, and you need to start and to launch the simulation many times, then you will be able to benefit from this improvement of the global computation. So now let's talk a little bit about the real-time target pack. So you have a new feature dedicated for vehicle in the loop, hardware in the loop, and anytime that you need real-time, hard real-time application. And we have worked a lot on different projects that we had for driving simulator, for vehicle in the loop. So you know, vehicle in the loop are use cases where you can put your complete vehicle in the simulation loop, and also hardware in the loop where you need to include ECU, for example, or a sensor, real sensor in the simulation loop. So some example of project of vehicle in the loop. So we have different kind of vehicle in the loop, but the idea is always the same: is that you keep the complete vehicle and the complete electronical architecture of the vehicle in the loop, so you can test the real ECU in the car, and you can input for the vehicle a virtual environment. So an example of a vehicle in the loop, so you can have data fusion to have the acquisition of the position of the vehicle on the test track. You can use a test track, virtual test track that is very close to the real one. In SCANeR Studio, we get the vehicle state, and you can input to the vehicle the virtual environment and the sensor data. So just to explain you how it works, so you have the equipped vehicle on the test track. You have high quality positioning system, so you can have exactly the same position of the vehicle in your real environment and in your virtual environment. So vehicle are exactly at the same location. And it is interesting because you can also modify the virtual environment, so you can add new road configuration, for example, even if it doesn't match your real road. Then what is really interesting, of course, is that you can run many virtual scenarios. So on this virtual environment, you can put new vehicle, new actors, and design a new situation. You can also virtually simulate the sensor, so all your virtual elements of your scenario will be detected, and you can feed your real vehicle back with this virtual perception of the scene, but you feed back to the real ECU, okay? And you can, for example, trigger an emergency braking maneuver with your virtual scenario. So you see on the real scene, you don't have any particular obstacle, but it will react to your virtual scenario and to your virtual obstacle. So it is very interesting to pre-validate your system, the performance of your system, by with the real vehicle. So it's the real architecture, it's the real system. You can adjust the parameters of your system with many virtual scenario on the test track. We also provide many improvements in all the features that we have in this pack. So we support a new version of NI Veriston. We also have a Simplify installation and license, and we have feature for vehicle in the loop application. So a new set of feature for the open platform and standardization. So it's always important for us to be very well compatible with different standards. So the first standard that we support is OpenCRG. Okay, it's which is a standard for describing road surface. So it's a kind of elevation grid that can be profiled along axis, and that you can directly input and apply on some portion of the road in SCANeR, so that you can have this different kind of road surface configuration apply on your virtual road. We also provide a new feature for enabling the connection with ROS application. So we have this new module which is named RosBridge, which is a very generic bridge to connect SCANeR with a ROS application. So it's very flexible. You have different kind of plugin. You can choose exactly which kind of sensor message you want to provide to your ROS application. You can choose how you want to be able to control the vehicle. You can also use some display and to use this display in the sensor of your module, and I will show you this module just after. And we have also a dedicated plugin for connecting to AutoWare, so you don't have to convert and program any converter to adapt to specific AutoWare messages. We provide a plugin that will do all the tricks for you. A new feature, another standard that we support is the ADASIS V2 protocol for the eHorizon application. So we provide a new eHorizon sensor, and the eHorizon sensor is a sensor that will use digital map to deliver information to the vehicle route. And this sensor provides information with the ADASIS protocol. So it's a way to use maps to detect road curvature, road traffic sign, road topology and configuration, and it will be able to feed back your ADAS system with the ADASIS protocol. Okay, that brings us to this sensor modeling feature. So we have this new light sensor, virtual sensor that is capable of sensing the lighting condition of your simulation. So this is very interesting if you want to be able to measure precisely what is the luminance perceived by your car. So it takes into account the time of day, the sun position in the sky. So you see we have a scenario with the sun rising. It takes also into account the cloud curvature or all the shadow that you have in your scene. So if you have masking or shadow, the luminance will decrease. If you have a tunnel with light, we take into account that you don't see the sky, you don't see the sun, but you have some light. You see the influence of this light on the perceived luminance. And of course, even for more complex scene where you will have trees and you will have building, and when you have different kind of shadow, all of this is taken into account. So it can be very useful if you want to simulate a real light sensor embedded in the car, and it can also be interesting to have this very precise environmental perception that you can use to create some more advanced noise model for the sensor. So if you want to take into account the fact that a camera sensor, for example, have some errors or or more errors in the detection when the luminance is low, or when the sun is in front of the camera. This can be perceived by the sensor, and this can be used as an input to adjust the sensor and the error models for your sensors. We also have a new feature for directly produce physics-based material for your physics-based sensor. So the work that we are currently doing with Octal SE, with this feature, you can produce terrain that are already physicalized. So you can choose the properties, the physical properties of the terrain in SCANeR Studio Terrain, and directly export your terrain, and you won't have to do any manual modification on this terrain. It will be directly taken into account. Which brings us to this new physics-based Lidar model, which is the L2 Lidar model, which we have developed with Octal SE. So it's a more advanced Lidar model than the L1, because it really takes into account the physics, and you have a beam shape, conic beam shape for every rays of the Lidar. So you can have a surface perception for each rays. It takes into account the laser beam intensity. You can also takes into account the physics of the materials that are collided by the ray, and the precise radiance will be computed for each rays, and you have a specific beam shape, and you can simulate multiple echoes for each rays, and you will get multiple target hits for each rays, which is very interesting and very close to a real Lidar sensor. We have also this new sensor viewer module. So sensor viewer is a new tool which is very useful to debug perception or decision from your ADAS system, and you can have multiple display, and on this display you will be able to overlay all the detection from your sensors, and you can have detection from your multiple sensor, and you can also produce your own data, so the decision of your data, and you have the flexibility to define exactly all the data that you want to overlay on this tool. So it's very interesting, because when you have a problem with your ADAS system, for example, you can define where the problem comes from. If the problem comes from a detection by a specific sensor, if the problem comes from a fusion, so you can evaluate that the data, your fusion data is incorrect, or if your problem comes from the decision, from the trajectory that has been computed, for example, or from the action, and the fact that the trajectory was good, but that the system was not able to follow this trajectory. So very useful, because you can overlay a lot of information and directly on the top of the scene. So it's very convenient to understand and to visualize the problems. And so we are almost at the end. Now the subject is about the new feature for massive simulation. So we are providing some new tools and some new improvement for deploying SCANeR in the cloud, and we have developed two new features for that. A new plugin API for SCANeR Explorer to be able to provide new feature to connect to specific cloud, and a new tool, SCANeR BatchTool, which is very convenient to manage SCANeR configuration and data. So let me just explain to you the first topic, which is this new SCANeR Explore plugin API. So the aim is this API is to allow to connect SCANeR Explore with any cloud platform. So what you can do first is that you can use Explore on your desktop. So what do you do when you do that? You have this local plugin that will handle everything for you on your desktop. Okay, so the plugin will be able, for example, to generate a new scenario, and this scenario will be stored, generate and store locally. Then you can trigger the computation, so you can choose the number of SCANeR compute instance that you want to use to compute all this scenario, and the local plugin will trigger and execute SCANeR compute with the proper option to run this scenario. They will produce results, and this plugin will get all the results for you, and we'll be able to store them, to post-process them, and to provide some reports. So it's exactly the same behavior that you have, but you have to know that all this is managed by a local plugin. Okay. But what can you do if you want to do it also in the cloud? So you have your cloud platform and you want to do exactly the same thing because you have more scenario to compute. You want to do the same thing, but compute it in your cloud platform. So what you do for that? You can program, and we also provide plugin for different platform. You can program your own user plugin, and the plugin will be able to connect to the massive platform or to the HPC platform to trigger the generation of the scenario that can be then generated directly on the cloud platform, which is more efficient because you don't have to upload all the scenario. It will also trigger the SCANeR compute for you, and of course, because you are on a cloud environment, you can run in parallel a very high number of SCANeR compute instance, and exactly the same thing, gather the results and get the results locally, or at least the report locally, and to produce the report for the user. So it's a new feature that will allow to connect SCANeR Explore to any new HPC or user massive cloud massive simulation platform. But to do that, you will have to manage SCANeR data, SCANeR configuration, SCANeR scenario, and SCANeR option. And to do that, you can use this new tool, which is a SCANeR BatchTool, which is a command line tool with many options, and it will help you to deal with configuration scenario options. So you can programmably use that to read a configuration, pack configuration, get scenario, pack scenario, of the scenario with all their dependencies, some option of the configuration, pack all this, send it to the cloud, and once you are in the cloud, automatically unpack and install locally all the configuration. So it's very useful to reflect exactly the local configuration that you have to be able to use it in another simulation configuration. So the example that we gave is for massive simulation, but you understand that it can also be very useful day to day to automatically manipulate SCANeR configuration. Okay, so I've presented you all these many features that we have for this new version of SCANeR. So I propose you a small recap of all these new features, because I know that I've been talking a lot, and that we have a lot of features. So what you have to remind is that we have this new physics-based rendering, which is already available in beta version, and there is also many improvements to come this year, but it's available. You can still try it and use it. We also have many new standard supports, so ADASIS for the horizon, a new RosBridge, and the support of this ASAM OpenCRG road surface format. We have new sensors, a light sensor, and a new L2 physics-based Lidar sensor. We have many new features for vehicle in the loop application, many tools for simplifying the deployment of massive simulation, and also this new sensor viewer, of course, in addition with many new feature and improvement of the performance and of the usability of SCANeR. So thank you very much for your attention. I hope that I've not been too quick and too fast. We are now available for some question and answers. So if you have any question, please don't hesitate to write them in the chat, and I will be very happy to answer to your question.
Well, thank you, Thomas, for your presentation. So we already have a few questions. The first one, which is, what is the status of the new Unreal rendering module, and what are the next steps?
Okay, thank you, Mathilde, for this question. So, yes, the status, to be clear, we have worked a lot to put everything in place. So you have all these new architecture that I've presented, and these many workflows that are available. So a simple application where you can just run SCANeR and with your existing assets and run them in this new module, and new workflow also to convert everything. So it is a beta version, so which means that we know that we can still have some problem with performance and some limitation in the feature. So it's not feature complete compared to all the features that we have in SCANeR, but it's already usable. We can do some feedback, and we are really improving all of this. And the next step will be to support multiple screens. So in the version that is coming in May, we have the support for multiple screen with synchronization and blending and warping to get closer to the driving simulator application. And by the end of the year, we will be feature complete for driving simulator application, and for ADAS application to simulate also a camera.
Okay, thank you very much, Thomas. So, second question, do you also support OpenScenario and OpenDrive standards?
So we support OpenDrive. So we have been supporting OpenDrive for quite a while, and we are always improving the support of the standard, and we are exchanging with many customers that are using many OpenDrive for many providers. The difficulty that we have is that each provider or each tool can have its own interpretation of the standards. So we always need to adapt a little bit the way it is handled, but still we have this very strong support of OpenDrive. OpenScenario is more difficult because it's a more recent format that it's still not very mature, but we are in the process of supporting it, which means that we are working on it. It's not yet available in the product because we think that it's all the features that are available are not yet sufficient for a standard or a common user. but it will come very soon. So stay tuned or contact us if you have specific application for that.
Okay, the next one. Can you provide a full vehicle-in-the-loop simulator?
Yes, so we are doing both, in fact. So we are improving SCANeR for many features related to help with the setup of this kind of new simulator. Okay, so there are a lot of new feature that comes with SCANeR, but we also at AV Simulation we also provide complete project and complete simulators, and we are currently we have project for different kind of vehicle in the loop. So we have a project with a partner for static vehicle in the loop simulator. So the one where your vehicle doesn't move on the test track, but it's in a room, but you have dyno motors on the wheel. Okay. So we have a static vehicle in the loop project, and we are also delivering dynamic vehicle in the loop project with also with partner to instrument a real equip a real vehicle and to connect SCANeR to this. So if you have any project for vehicle in the loop application, we'll be more happy to help and to provide a complete ready to use vehicle in the loop simulator for you.
Well, thank you very much, Thomas. So this is for now the last question. What kind of physics-based sensor model do you provide?
Okay, so you know that we have this different level of modeling for the sensor. So we have the L1 model, which is not physics-based, but where we support any kind of model. So we have radar, Lidar, camera, ultrasonic, horizon, light, and so on. For the physics-based model, we have started by the radar. So we have radar at L2 and L3. So L2 for us means real-time physics-based, which is very realistic physics-based, but tailored for real-time. And we have this L3, which is the full physics-based with all the details. So you can really activate all the multiple world section and go very far in the radar modeling. So radar, we have these two level of modeling, and now we have the Lidar, which is a level 2, which means physics-based and real-time. And with this new rendering engine, we also have the camera. So camera also physics-based modeling for the camera at level 2. Okay.
Do you support FLT and common database terrains?
Yes, we do support OpenFly. Okay, so OpenFly is a common format, and it can be natively used in the simulation or converted with your standard data flow. Not yet CDB. So CDB is we are still studying that, but what is very interesting is that as we have this new workflow with Unreal, I know that there are some plugins in Unreal to support CDB. So it's not something that we have been evaluating yet, but one option could be to use Unreal to support that. So it's something that we are studying at the moment.
Thank you very much. Well, for now, I don't see any other question in the chat. So we have 10 minutes left. Don't hesitate to ask questions. Or maybe I think we're done for now. Okay. Well, thank you very much for your participation. I hope you enjoyed the session. Again, Thomas, thank you very much for this very interesting presentation.
Okay, thank you very much. So if you have any further question, of course, we are. You can contact us or contact your cell representative. We would be very happy to support you.